We have some general goals of saving energy dollars, identifying energy efficient equipment upgrades, reducing energy use for environmental reasons, and some of those reasons might be climate action plans or CO2 reduction plans. And Todd will speak to some of those as we go along, some of the community-oriented plans. Illinois Energy Now is a partnership led by the Department of Commerce and Economic Opportunity, and it encompasses the umbrella for all of the energy savings programs throughout the state. SEDAC's a part of that, along with the Energy Resource Center in Chicago at UIC, and Midwest Energy Efficiency Alliance, MIA, and SEDAC down here in Champaign, along with a group in Chicago at the 360 Energy Group. Just a little diagram of sort of how the money flows. So the Energy Efficiency Portfolio Standard, EEPS, is what helps pay for these free programs that we offer. And so we have ComEd and Ameren collect on the bill, and we'll show the bill in a second. ComEd and Ameren collect rider, an energy efficiency rider on the electric bill, and NICOR, Peoples North Shore, and Ameren Gas collect on the gas bill. And this money goes towards electric efficiency and gas efficiency pots. I can grab the pointer just in case that helps. So we have the electric efficiency pot, the gas efficiency pot, and about 75% of that pot goes towards the public sector, the private sector, businesses, residences, and nonprofits. Then about 25% goes to DCEO for public sector buildings. So incentives for public sector government buildings, K-12 schools, community colleges, public universities. There's also a low-income residential, affordable housing, public housing segment as well. Now, SEDAC helps give energy audits and advice and recommendations to all of the above. So private sector, public sector, businesses, not-for-profits, schools, governments, really all the above. We don't do as much residential, small residential, although we do some multifamily residential. I mentioned the bills. So here's a typical Ameren bill, and down here, one of the mini riders. So here's an EDR, energy efficiency and demand response rider for 1/10 of a cent per kilowatt hour, and that's what helps pay for both the energy efficiency audits, but also the majority of that is for lighting upgrades, boiler upgrades, efficiency upgrades that we'll talk about with some of our case studies today. Who we are. So SEDAC is a public-private partnership administered through the Department of Commerce in Springfield. Here today, Todd and I are both at the University of Illinois. We have staff, faculty, and students here in our group. There's a private sector that we contract with, the 360 Energy Group, so the private sector energy specialists, and that's part of that public-private partnership that we think strengthens our program and helps distribute resources and energy audits throughout the state to private companies as well that subcontract. Then there's also, we mentioned, the UIC Energy Resource Center in Chicago. And our goal is to help reduce the energy footprint of the state of Illinois. What we do, so our free services, this is part of our outreach and training. We also, maybe our bread and butter is energy assistance and assessments. We have some new construction projects, and this year the new construction has increased greatly, I think, with the economy rebounding. We've had quite a lot of public sector, especially new construction projects, increasing. We do program support for DCEO. We do retro commissioning for the public sector. We do some mini retro commissioning projects as well. So we have some pilot projects like dashboards and mini RCX projects for the public sector as well. But we do public and private. Some of the more involved retro commissioning, we happen to do the public side of that. And there are ComEd and Ameren and NICOR and analogous programs as well for the private side. Here's just a photo of some of our staff here in the Champaign office, looking bright and cheery on a crisp spring morning that a couple years ago that was pretty similar to the day we had yesterday when the sun was out and it just started to reach 50 degrees outside. Let's see. So just briefly, we have a one-page application for people that are interested, for clients. Pretty straightforward. We ask for very simple things: square footage of the building, what your planning horizon is, what kind of projects you might be thinking about, and utility, electric and gas account numbers and just a vague idea of how much energy you're using and how many square feet, so we can start to prioritize and figure out where you are in benchmarking terms, which we'll talk about here shortly. Just a brief overview of the presentation today. We have some case studies that we've interspersed throughout, some individual buildings. Todd's going to speak to some of the community-wide efforts, some energy efficiency planning, paying for energy efficiency, and resources that are available, both us and our partners and throughout the state. I think I'll put the presentation, I'll put the video off for a second so we have more room for details of some of these slides. Here's an example site building. So we have a 2001 high school. This was up north in Illinois, and they had fairly standard construction at the time, at a constant volume system with reheat, which could be better, but they had standard efficiency boilers, which again could be better. But one year they ran out of money in their energy budget. So that's illustrated down here in this bar chart, that the 2009-2010 school year, they used 200 kBTU per square foot per year. So they're using, per square foot, they're using 50 to 70% more than they were in the previous 2 years. And quite a lot more than we would have guessed based on Energy Star Target Finder of what an Energy Star school should have been. So what we did first was we looked at their gas and electric bills. So we plotted the gas and electric bills here over the course of a couple of years. So here's the heating degree days compared to the gas use, and they roughly follow, the trend is roughly following the heating use. So there's not a whole lot of heating use in the summer, and there's more in the winter. That's pretty typical, and that's what we would expect to see. Electric use, there were some years where they didn't have any school during the summer, but then in 2008 they had summer school, so that's expected that they would have more electric use in the summer when they have summer school and more air conditioning load. There are a couple outliers in the electricity, which maybe are signs of problems to come, or maybe they're just outliers. Sometimes bills get a little bit funny, or sometimes maybe a chiller is being worked on and gets serviced at a different time of year. But the next slide will show that things go crazy. So here we have, in the gas use, all of a sudden we have a lot of gas use in the summertime, which we didn't have before, and the gas use every month is well above what we would have expected based on the typical heating for that year, for the heating degree days for that year. Likewise, on the electricity, we're just spiking electricity per month. Every month is higher than it used to be, and some months are extraordinarily high. So what we ended up seeing in this school, one of our recommendations was to look at the systems, the heating and cooling systems, and to perform some retrocommissioning. So looking at these systems, making sure these systems weren't fighting each other. What we found was that these systems were running 24 hours a day. They broke on, so they got stuck on, and both systems were stuck on, so they were both essentially fighting each other. The air conditioning was running excessively, and then the reheat was running excessively to cool that air conditioning down at the room level. And they were running 24 hours a day. So a glitch in the system caused the computer to be confused about when to shut down, and it just stayed on 24 hours a day. The nice thing then is that we have some data from after they made changes. So after they caught this problem, and we and Train performed the retrocommissioning in this case, but we identified some of these potential savings, and they had a contractor come in and fix the building automation system. And notice the electricity use goes back to normal. The gas use goes back to normal. The electricity use goes maybe even lower than it ever had been before. And they very little use during the summer, which is a great sign. And then even the winter use, we're not seeing any of these months where it's sticking out above the baseline. So this was excellent. This was a really nice example of what can go wrong and what can be fixed. This was our recommendation, was to get down to this package of savings. So we put together a whole list of savings recommendations, one of which was retrocommissioning that also included potentially new boilers and some new lighting. So we think that they could get down into the range of, let's say, 90 or 80 kBTU per square foot per year. Target Finder thinks they could be a little bit lower. But we also identify in that report, we identify what these gas incentives would be and the electric incentives would be. And the annual savings here was $160,000 a year of potential savings. So really excellent potential for savings. When we put them on a benchmarking graph, so if we compare their energy use per square foot compared to all of their neighbors, then we see in the bad year over here They were up here at 200 kBTU. In the year before that, even then they were at 110 or so. But once they fixed the systems, now they're back down to this sort of 80 or so, the recommended level, and they're right around sort of the median value, a typical value for their peers. So that's excellent to see. Some of the top 10 strategies that we recommend for all buildings, especially retrofits, are lighting measures are usually a major item, plug loads, computers and heaters, and making sure that they're turned off at night or going to sleep or not plugged in at all if they're not needed. Ventilation, heating and cooling, motors and pumps, building automation system, commissioning. These are all starting to get a little bit more costly as we go down the list. Once we get into the building envelope, the building's already built. So air sealing is one of the few things you can do that's not too costly, but adding insulation and adding windows or replacing is very expensive. And we see that sometimes. We have some case studies that do that, but very expensive items. And after all these are done, then looking at extra credit, waiting to do solar or wind or any sort of renewables once all of these loads have been reduced. So a lot of times people are really excited about renewables and that helps motivate them, but there really are the low-hanging fruit and the lower cost measures are almost always cheaper. With the exception maybe being something like windows. I mean, certainly as solars become cheaper, windows seem more expensive again. Here's an example of an elementary school that we worked with, a case study. And this is what they did. So they replaced their existing boiler and their existing chiller with a high efficiency condensing boiler and a higher efficiency chiller. They did put in new windows. They had single pane windows before, and they were pretty leaky with aluminum frames. So they were pretty much the worst case scenario window you could have. And some of them were failing as well. They did a retrofit of their lighting. They went from T12 to T8 linear fluorescent and put occupancy sensor in classrooms so that they are turning off at night when no one's in there. And air sealing. There was quite a lot of air sealing potential in this school. So they had annual energy savings of about $17,000. They had a DCO incentive of $30,000, and their total project cost was something in the $140,000 range. So this leads to a 6.5 year payback, which is pretty good, especially considering they did some pretty expensive windows in here. I think some of the lower cost measures like air sealing and lighting helped reduce the more expensive windows and boiler measures. Here is an example of, we mentioned bad windows. This is an example of not this school. This is a building we went to, and the occupants were complaining they were cold. It was a hospital. They had two problems. One problem was the windows here were showing very, very cold frames. So these are an example of what happens when you buy insulated glass windows, double pane windows, but the frames were not insulated. So we're getting very cold spots. Up here is 45 degrees. It might even be a little cooler, 41 degrees down here in the coldest spot of the window. So the people sitting near windows were chilly, partly because of all this framing that's cold. But even in the walls, they had not put in a continuous layer of insulation when they framed the walls. So here you can see where the studs are in each one of these frame members. So that's keeping those occupants cold that are near the walls. And this is something that's not very easy to go back and take drywall off and retrofit. So this particular building is going to have to deal with this problem and these comfort problems unless they put some serious cost into re-insulating, which is difficult, or maybe putting in some strip heaters or reorienting people so that people aren't sitting next to cold walls. Here's another example. So this is a school in the same district as the previous one. Now they added geothermal in this case. They did not already have a chiller and they didn't already have chilled water pipes throughout the building, but they wanted to have air conditioning. So right away, this is going to be a slightly more expensive scenario because they're adding a system, they're adding cooling to the building, but they're also choosing a really high efficiency cooling of geothermal. They also did new windows, they retrofit lighting, occupancy sensors, air sealing. At the time, this was not completed yet, but I believe it is now. We have some photos in the next slide of the completed air sealing. So if you look down at the bottom line of this one, this has a much longer payback. So this has a 29-year payback, and that's really due to adding a whole new system that wasn't existing before, adding air conditioning that wasn't existing before, and geothermal is more expensive. That's a very expensive system to put in, very efficient. Notice they're having nearly $20,000 a year of annual energy savings. So they looked for grants, exterior grants, further funding opportunities to help draw down the cost. They received DCO incentives, but I think they also were able to lower this cost through some external grants as well. So looking for those other kinds of grants is also important. Here's a picture of the air sealing in that particular school. So when we went in and they were replacing the ceiling, you could basically just see daylight outside if you stuck your head above the ceiling tiles. So there's this big gap between the wall and the roof system. So going in and they spray foamed insulation when they were redoing the ceiling and redoing the lighting. And that has a huge energy savings component to it. We do new construction as well. So here's a new construction case study of a recreation center. They went to high efficiency LED lighting. They did a high efficiency geothermal system for their HVAC. They did better insulation than they otherwise would have, and they also reclaimed some domestic hot water. They create some hot water from the geothermal system in the summer. So in this case, the simple payback was 5 years compared to the systems that they would have otherwise put in this case. Now they didn't model this in this case. They used the prescriptive incentives that we use in our program. Some scenarios model the building energy use, and that's an excellent way to go about it. It's a little bit more expensive or a little bit more timely, but we also have a way to do prescriptive new construction incentives. So this was a good example of nice daylighting and nice lighting use and good high efficiency systems. All right, I think I'm going to turn it over to Todd to talk about some of the energy efficiency planning now.
Okay. Thanks, Andy. Okay, so Andy talked about some really interesting case studies that go into detail into specific buildings. And so now I'd like to zoom out and look more at the bigger view, say looking at a community, and I'm going to focus particularly on communities that are looking on the portfolio of buildings that they own. So we're going to be talking about the city buildings, the school districts, the water and wastewater treatment plants, police stations, fire stations, libraries, whatever is in the city portfolio. And I understand that every place is different, and the city can't always touch the schools, and the schools can't touch the park district, and everyone has their own boundaries. But the idea here is to kind of get you to start thinking about holistic planning from a community basis. And so to start, one important topic in energy efficiency planning is to get a sense of what's the portfolio of assets that is in your scope of interest and also in your scope of influence. And so we can call this a portfolio analysis. And I'll just say right now that here at SEDAC we tend to focus on buildings and some on street lighting, but we focus heavily on buildings. And so while we're on the topic of community energy planning, I just want to point out, let's just be sure that we remember street lighting and that we remember fleet vehicles, because they're also important in the context of community energy planning. So back to the portfolio analysis. We can, once you have a sense of the buildings and the assets that are in your portfolio and your scope of interest and what you can influence, then you want to be able to characterize those and look at them all at the same time. What is their energy impact? What is their financial impact? And how do they compare? How do they compare with each other? But how do they also compare with regionally appropriate benchmarks? If I want to talk about a particular library, it might make sense if I compare that library to other libraries in a similar geographic region. And so fortunately, we have lots of information available on benchmarking buildings to others that are like them in the appropriate geographic area. And the point of all this is to get down to the tasks of actually doing things. And so you know, when we all have limited time and limited funding, and so when we are doing work, we want to make sure that we're prioritizing our actions and acting in a way that you know, gives the most bang for the buck. And so when we have gone through our process of prioritizing, we can go out and do assessments, and we can use our analysis methods to also track progress. And I'd also like to put in a plug for doing a portfolio analysis. Really handy tool to use. I see lots of organizations and communities using it. Is the Energy Star Portfolio Manager. You know, you can use your own custom spreadsheets, and there's times when it's important to do that. But the Portfolio Manager makes it really easy to get your physical data in on the assets, and also to put in the energy consumption data. So on the portfolio analysis, I'll give a couple of different examples of some of the steps in a portfolio analysis. We have worked with Rockford Public Schools, and so they have on this graph on the horizontal x-axis, you can see about 53 buildings in the portfolio that's being analyzed. And so the idea here is, again, let's prioritize our effort and find out where we want to invest our energy and our analysis. And so the graph up on the top is about energy use intensity. And so this was a term that Andy introduced earlier when he mentioned units of kBTU per square foot per year. And so what that means is it's an indication of how much energy a building is using normalized to the size of the building. So when we're talking about the size of the building in terms of square footage. So on the energy use intensity, this is just one metric we want to look at when we're analyzing the portfolio. And one way to prioritize is to, you know, we look at where is the most opportunity. And one way to look at that is the buildings that have the highest energy intensity, they tend to have higher savings potential. Another metric, if we look on the graph on the bottom, is the annual energy cost. And so this is just an absolute measure of how much, sorry about that, it's just an absolute measure of how much are we spending on an annual basis on a particular building. So if I'm just looking at these two graphs and trying to make some decisions on next steps about where we go with the analysis, I'm going to look at buildings that have high energy use intensity, and I'm going to look at some of the buildings that have higher energy costs.
The bigger square footage.
Some of the bigger square footage buildings. So another case study is City Colleges of Chicago. This is a smaller portfolio of buildings, and actually I think these are several different campuses of colleges. And so this is a similar analysis as what we talked about on the previous slides. We can see the energy use intensity up here, and we see the annual energy costs. And so just from a quick look at this portfolio, I see on building or campus 3 and number 5 here, we have both high energy use intensity and we have high annual energy costs. And so one thing that we can do with that is by doing some analysis of what we expect on a benchmarking basis, and just in some rules of thumb, and what we expect for energy use in buildings is that we can assemble a graph that represents the annual savings potential in a building. And so this would just be another step that we can go when figuring out where we want to put our effort and invest our time. And so, based on these, I would want to look at these two first. So that's just really quick introduction on some of the metrics we would want to look at when doing a portfolio analysis, and I'll just show those again: the energy use intensity and the annual energy cost. And there's all kinds of other metrics that you can use. You can look at total energy consumption, and you just, when you get into it, you have to figure out what is the most appropriate and what works the best for your particular case. So now we go into, you've done some of the initial analysis of your portfolio, and kind of figuring out how do we get this done, and where do we go from here? And many of you that work in large organizations or doing work in communities, that there's a whole bunch of things going on inside that community. There's all kinds of different initiatives. Community and economic development are always important. We're seeing an increase in interest in sustainability planning and climate action planning, and lots of people have observed that if you can integrate, the more that you can integrate your energy efficiency planning with initiatives that already exist, you'll be better off. And so on that second bullet point, when we see capital planning and infrastructure projects or community and economic development, we recognize that a lot of these projects, they can be financially attractive, but they can also be very cost intensive. And so if we are smart about how we plan and coordinate these with other initiatives that are going on, particularly with infrastructure projects, it's kind of like, when Andy was talking about new construction, it's easiest and most affordable to get these kind of projects done when you're in the planning and design and building phase, rather than trying to retrofit something, onto structures that exist already. And then another area that we can go with energy efficiency planning is in policy. And that's what local governments do, is they enact and enforce policy. And so some of the common things that we've seen with energy efficiency and in the intersection with policy and local governments would be green procurement standards, building standards. There are communities that, and this could be for the municipally owned building stock, or this could be setting precedent for the residential and the commercial building stock, and that's just, that's a community by community basis. But one example of things that we see in terms of building standards, we will see standards that specify LEED certification as a goal or as a requirement for new construction projects. We also see that there are building energy codes that give guidance on how buildings are to be constructed and to perform, and so that is a place where communities can have influence on what happens, and it can even be enforcing their own building stock. So there's the energy codes, and then there's also the enforcement of those energy codes. And lots of you probably know that those are tricky and contentious areas, but there's a lot of room for community-wide and just big improvements by having an effect in those areas. So some examples of just real quick examples of some things that some communities are doing, and I'm not going to pretend that this is an exhaustive list of all the things that these particular communities are doing, but these are some that we have relationships with. Will County We've done lots of building energy projects with Will County. I believe that's the planning division. And one of the things that helps with Will County is that they have a county energy plan. And so when it comes to energy efficiency, there's a context that specifies a political will and desire to make those changes. And so they've done really well with setting up their Energy Star portfolio manager and doing some targeted energy efficiency improvements, particularly with lighting and controls, adjusting thermostat settings and unoccupied setbacks for the thermostats, all kinds of things that you can do with HVAC settings, and then roof and envelope improvements as well. And Will County was, I believe it was in the last year or maybe in the last 2 years, they were recognized by the Department of Energy for some of their progress and participation in the Better Buildings Challenge. Another community that I have, so I'm familiar with Urbana. I live there, and I'm also a member of the Sustainability Advisory Commission. So Urbana has a climate action plan. We also have a staff member whose title is Sustainability Manager. And so having that as a context and a precedent for, from which lots of, energy and sustainability initiatives, it really helps. And so some of the things going on in Urbana, there's an Energy Star challenge. And this is Urbana and Champaign. And this is a participation between Energy Star, the local communities, lots of public, private, university, building owners, and operators. And so they're working on doing, benchmarking their own building energy performance. And I believe now they are in the phase of trying to track and register building energy improvements. We have another interesting initiative. The city, in collaboration with a really interesting group of community activists, is participating in the Georgetown University Energy Prize. And so this is a little bit of a friendly competition between communities around the U.S. And the idea is to realize the greatest energy savings on the residential and the municipal sectors, and so that's a way that we're trying to encourage and get some interest in making some improvements on the municipal sector, and then also getting some discussion and action groups in between neighbors and in their own homes. And then other things the city has done. Looking at energy assessments of all the major municipally owned buildings and the street lighting. One thing I would mention about street lighting, and I'm not sure how it is now, but a few years ago when I was looking at City of Urbana energy use overall, I believe that about 40% approximately of the energy costs for the city portfolio was in street lighting. And other community, I looked at another community within the last several years, and I believe it was around 20%. So there's a lot of your energy expense in the street lighting. Let's see, other things the city has done. We're working on drafting a green procurement policy right now. There's a staff green team, and then the city has participated in a municipal aggregation program to get all of the residential electricity accounts to be using certified green RECs. Those are renewable energy certificates. And so the idea is essentially that all of residential accounts that have not specifically opted out are 100% renewable electricity. And then I think this is the last community I was going to talk about. This is the village of Rantoul. And Village of Rantoul, like many communities, has been working on community and economic revitalization, and so they have a plan called the Community Experience Plan. And one of the components of that is really, reinvigorating and bringing life to the downtown. And so one of the ideas was to evaluate the use of LED street lighting in the context of the downtown revitalization as a way of finding justification for the investment, but then also there's also an understanding there could be a role for financing to help pay for the high efficiency street lighting, and so they're looking into that. Elsewhere in the community, there's interest in renewable energy, and so there's an investigation ongoing right now to look at the feasibility of installing renewable energy. That would be a solar photovoltaic, and that would be in participation with the municipal electric agency. And then another activity going on in Rantoul, just similar context. It's not necessarily related to energy, but a range of interesting initiatives, including local food. And so when we look at things that communities are doing and how we can give leverage to energy efficiency, if we consider the whole context and take advantage of that, it can really help things along. Okay, so now I want to get into how do we pay for energy efficiency? I think a lot of us understand that energy efficiency is there are lots of things that we can do that are economically attractive. Capital can be constrained at times, and so we need to look at this a little bit more creatively. So if we step back to our planning and assessment process, we've gone through our portfolio, we've done a plan, we've done some assessments to get a sense of what our opportunities are. We will have identified some immediate opportunities that are pretty easy to implement with cash that's on hand. And there will be some that are, that we can, plan to budget for in the near future. There will be others that are a little bit longer term, and we'll have to do some capital planning and figure out how to raise the money. So just that question again, how are we going to pay for it? And just like to put a plug in, first of all, to remind you all that there's lots of funding and assistance and incentives to help pay for these things. We have the Illinois Energy Now program, which provides lots of incentives for public and private sector. The idea is it's not going to pay for everything, but it will help with that. And so if you can include these incentives in your planning, that will make it easier to pay for. To give you just an overview of, I'm going to go through this pretty quickly, but you have it up here on the slide. There are lots of programs through Illinois Energy Now, lots of ways that you can take advantage of the resources, incentives that are available. And then in addition to Illinois Energy Now, there's lots of other funding opportunities. There's loans, there's grants, and other types of incentives. I've worked with a school recently that leveraged the State Board of Education grants. So keep an eye out for those.
Right, these are all moving targets, but sometimes they move back in range.
Yep. Okay, so now we've taken care of the incentives and the grants, but we still need the community to. The community still needs to invest, and so Andy presented some case studies where we saw examples of buildings or communities where they were willing or they were able to invest in long-term payback projects, but that's not everybody. we are not all able to immediately afford the 29-year payback. It's great to support those that do, but we don't all fall in that position. And one of the things that we find in lots of places, and these are really rough numbers, but when we see simple paybacks on projects that go much beyond 2 or 3 years, then some of these projects don't. I'm sorry, I confused that. We see that simple payback projects that are, 2 or 3 years, those are easy to pay for. Communities are willing to do those, almost immediately or plan for it in the next budget cycle. But when we get, we get a bottleneck, and we get lower implementation when we get longer term payback. And it's too bad about that, because there are a lot of really financially attractive opportunities, and if we can look a little bit more creatively at the financing opportunities, we can open up a whole new range of savings opportunities. And so when we want to go there, it's important to look a little bit more sophisticated measure than simple payback. So we start looking about life cycle cost analysis, looking at internal rates of return and net present value, and we can start looking towards finance. This could be from banks or from the bond market if the project is large enough. We can look with energy service companies or energy performance contracting for third-party means to finance and to basically do a turnkey installation of a project. But when we look at the financing opportunities, it changes the equation on the availability of capital, and then instead of being constrained by really short paybacks, we can look at the overall cash flow and say, I have a 10-year payback project, but maybe it has a 10 or 12 internal rate of return. That's a pretty attractive investment in financial terms. And so if we can get the financing for that, we can see a benefit in our energy savings that will more than pay for the cost of the loan payment. That brings a really important responsibility and a need to be more careful about your energy planning and your understanding of the savings and the and maybe the sensitivity analysis on some of the things that could affect the affordability of that loan. But even with that, it opens up a lot of opportunities that people are not considering right now. We're getting close to the end now, but wanted to point out some resources here. Of course, there's SEDAC, Smart Energy Design Assistance Center, and Illinois Energy Now. Put out a plug again for Energy Star Portfolio Manager. Will really help you with analyzing your portfolio of energy using assets. And then a couple of resources here at the bottom. These are more technical manuals, and I think these are for I think communities and organizations that are really ready to go for it and to invest staff time and expertise. And so if you find yourself in that position, then the local technical assistance toolkit and some of the resources from the U.S. Department of Energy will really help you do a deeper dive on doing energy efficiency in your community. And just to summarize and close out, let's remember that there's funding available for almost any energy efficiency project. There's lots of services that are available at no cost, and there's lots of resources that can help you implement. If you go to the SEDAC Energy, the SEDAC website, we have a presentation on case studies and resources, And then I'd just like to encourage you all to, get started in your community and your buildings and get going on your planning process, because you can start to save a lot of money right now.
Well, thank you. Thank you very much, gentlemen. Andy, Todd, that was a really great presentation, and obviously you have a tremendous amount of services to offer, from identifying issues to solving them to funding, and then again, tremendous resources that you can point people to. So we're going to open it up to questions. We do have about 9 minutes for questions. So like I said earlier, go ahead and type those questions in the chat box there, and we'll get them answered for you. I have a request for all the participants. If you have a number of people with you in the room listening to this webinar, watching this webinar, if you can go ahead and also let me know how many people are with you, that will help us determine how many participants we actually have on this. That would be helpful for me too. So if you could do that for me, I'd appreciate it. I know we have several people typing, so I'll give you a moment for those to come through. And we've got one from Kathy that says, perhaps this has been covered, but how does the community access your services?
Sure. So we mentioned at the beginning, we have on our website, we have an application process. So we have a one-page application for a community or for a building level audit. If it was a community that was interested in more of a portfolio analysis across a school district, say, or across many buildings, certainly you could use that one-page application, and there's an area for notes, and you can say, well, we're interested in talking about portfolio of buildings, or maybe we're not applying for one building just yet, but we'd like some help on the initial steps, and certainly we can do that as well.
Great. And is this website that's up on the slide that we're seeing, is that a way that they can get to your website?
Well, let's see. So that's Illinois Energy Now, which is the umbrella. If we go back one page, so SEDAC.org also has more of our specific information. And our 800 number is for SEDAC and Illinois Energy Now. We help handle all the calls for Illinois Energy Now questions that come through the SEDAC office. So either website would be helpful. I think I would go to SEDAC.org if you have a SEDAC-specific question.
Okay.
And if you have an incentive-specific question, that is more likely to be updated right away on, well, our website has notes of what the updates are, but the root information for incentives is on DCEO's Illinois Energy Now website.
Okay, great.
Really easy to apply for SEDAC. Go to SEDAC.org, and there's a button that says apply. And you just click it, and there it is.
Great. That's wonderful. The easier the better, I think. User-friendly.
And we have some videos linked there, some videos of case studies. We have some case study PDFs. We have some technical notes on specific technologies that keep coming up. We just did one on solar PV that's fairly updated, talking about the reduction in cost in solar PV, and some case studies that we've worked with some churches, some buildings, some large government labs that have been working with PV. So that's one of our new case studies, but I think Ann put a link to some of those up there earlier as well in the chat box.
Yes, she did.
And then another of our colleagues, Holly, just asked us to mention that we are currently developing a tech note on planning for energy efficiency, and we're going to publish that in spring. So that will be available soon.
Great. And we can find that on SEDAC.org as well.
Yeah,
that's right.
And SEDAC is comprised of, so we have a group here of, I have an engineering background. Todd and I are both engineering, but we have quite a few architects and quite a few urban planners. So we really try to cover the planning and the urban and the built and energy environment.
Okay, and I think we've got a question being typed. And thank you, D'Angelo, for telling us how many people are in your group. How often should you get an energy audit?
Let's see. So I would say that you should start with an energy audit, but you should probably, even after the energy audit, you should continue with benchmarking and with looking at your energy use. I like to look at my monthly energy use for clients of mine. I like to look at the energy use as they continue on. So sometimes I'll touch base with clients and say, have you installed that boiler yet? Have you done the air sealing yet? And if you have, I would love to see some of the bills. And help do a bill analysis. So I think ongoing analysis of the bills. We mentioned a little bit about retro commissioning earlier, and retro commissioning has to do with tuning up the building systems in these very complicated buildings that we have now in larger high schools and larger buildings. Even small libraries sometimes have fairly complicated systems. So those can go out of whack pretty easily. Like I said, a lightning strike can cause the computer to lose all of its schedules and keep the systems running all night long. Power outage, a glitch, a janitor that overrides a schedule and forgets to set it back. So there's a lot of things that can happen throughout the course of a year that cause our systems to maybe go haywire. So retro commissioning, I would say that's the kind of thing that really looking at it, maybe a full-scale retro commissioning audit every 3 to 5 years is not a bad idea. But continuously looking at bills, whether it's continuous commissioning or continuously plotting bills and looking at bills and keeping an eye on your energy use intensity to make sure it's not slipping and getting worse, or comparing it to weather like we did in some of those monthly bills compared to weather. I find that to be a very useful tool to see if I'm starting to slip. In that example we gave, the school district went maybe 16 months before they ran out of energy money in their budget. If they could have caught that in month 2 or earlier on 2 or 3 and said, well, it's more than just a blip in the bills. This is a trend and we need to solve it right away. I think that could be a really powerful tool to look at bills as you go.
There are a lot of developments with dashboard technology, energy dashboard technologies, and so they are making it easier for people to continuously look at their energy use and identify when something is going wrong. So don't always have to redo an energy audit, but if you have something to help you identify when something has changed or something's going wrong, then you can kind of target your investigation and look at what just happened here.
Well, if we don't have any more questions, well, D'Angelo's typing. He must have a follow-up question for you. Mm-hmm. He says thank you. So you must have answered his question.
Oh, great.
So if we don't have any more questions, I want to tell you about the next webinar in the climate change series that I mentioned that we're going to have, which is April 14th. It's called Green Infrastructure and Stormwater Management. So we hope that you can join us for that, and we thank you for joining us today for this webinar, and we thank the speakers Andy Robinson, Todd, Rusk from SEDAC. Thank you so much for being here with us today. It was great information, and we hope that people will start doing this immediately.
Great. Thank you, Amy, for setting this up.
Thank you.
Thank you. Everyone have a great day.
And good luck.